Whoa! Earth's surface is shaking. Long cracks split the ground open. Lava rivers are rapidly flowing down the slopes. Deafening noise is filling the air. Rocks and other debris are flying high up. Clouds of volcanic gas and ash cover the sky. Now, this is not a plot of a blockbuster disaster movie. It's what happens when supervolcanoes decide to erupt. But this is likely not the scenario that will take place when the world's largest volcano, Mauna Loa, decides to finish its long nap. In 2021, scientists were sure it would happen soon, but so far, nothing. The volcano's seismicity keeps increasing and then going back to normal, but you never know when this giant will finally come back to life. That's why experts have been monitoring geological activity on Hawaii's largest island for quite some time. The Big Island of Hawaii is made up of 5 volcanoes, including the most active on the planet, Kilauea, and the largest, Mauna Loa. This gigantic thing makes up almost half the landmass of the island. And what lava Kilauea emits in one day, Mauna Loa could spew out within 20 minutes. That's what it did in 1984. While Mauna Loa's smaller sibling has been throwing tantrums for a while, the giant has been slumbering ever since its last eruption. But very recently, the Hawaii Volcano Observatory has recorded more than 200 mini-earthquakes below Mauna Loa. It likely means an increased flow of magma down there. Good morning! The volcano might be waking up. Or not. If Mauna Loa did suddenly erupt, lava flows could reach the ocean and the most populated and touristy places, like Captain Cook, very quickly, in a matter of hours. In 1984, the last time the volcano erupted, lava got as far as the outskirts of Hilo on the other side of the island. That's where a campus of the University of Hawaii is found. Luckily, people had a few weeks' warning to get ready for the disaster. These days, locals have special go bags ready with the most important stuff, including documents and money. Such precautions can come in handy in case of an emergency evacuation. Even though most Mauna Loa eruptions have so far only affected the summit area, several of them sent lava all the way down to the ocean. And you never know how powerful the next eruption will be. Now, what is the highest mountain on Earth? Mount Everest, you say? Well, it depends. From seafloor to the summit, Mauna Loa is 1,000 feet taller than the famous Himalayan peak. The volcano is so big, it makes the Pacific plate it's sitting on literally slump under its weight. Scientists say that when this monster of a volcano erupts, the volume of lava coming out per unit will be life-threatening. Over its recorded history, Mauna Loa has been erupting regularly, almost every 6 years. And even though the last eruption of the volcano occurred about 40 years ago, scientists are certain it'll happen again. Now, remember the scene I showed you at the beginning? Well, you can relax. It's not likely to happen with Mauna Loa. The thing is, big island volcanoes, including Mauna Loa, aren't very volatile. That's because they're shield volcanoes. These volcanoes got such a name because they aren't really very high and resemble a warrior's shield placed flat on the ground. Shield volcanoes get formed by very fluid lava. It travels farther and forms much thinner flows than lava erupted from a stratovolcano, which is conically shaped and tall, like the infamous Krakatoa in Indonesia. So if, or should I say when, Mauna Loa erupts, there probably won't be ash clouds and tons of debris. The most dangerous thing will be lava. Since Mauna Loa is a shield volcano, its lava is extremely fluid and voluminous, which allows it to flow far and fast. Using theoretical vent maps, experts from the Hawaii Volcano Observatory have made charts of possible lava flows. They're kind of worried about earthquakes clustering at high rates. It likely means that lava is on the move under the surface. 500 to 600 earthquakes per day are a serious reason to be on high alert. On the other hand, it doesn't necessarily mean a disaster or inevitable eruption. Around a decade ago, several earthquakes that happened at the same time signaled that something was happening under Mauna Loa. But an eruption didn't occur. Instead, half the volcano shifted a bit to the south. This way, it probably gave more room to magma so that it had enough space to stay beneath the surface. Now, let's get back to the catastrophic eruption we saw at the beginning of the video. That's what often happens when a supervolcano erupts. Those are volcanoes that have at least once had an eruption with a volcanic explosivity index of 8, which is the largest recorded number on the index. Supervolcanoes are often extremely large, with no cone at all. That's because they're typically the remains of gigantic magma chambers that once flared up, leaving behind a caldera. They're usually found over hot spots. Supervolcanoes can produce super eruptions, and when they do, they blow more than 240 cubic miles of ash, molten rock, and hot gases up into the air. In other words, 4 super eruptions could fill the Grand Canyon to the brim. Supervolcanoes get formed when gigantic volumes of scorching hot magma are trying to escape from deep underground. This magma rises close to the surface but can't break through Earth's crust. That's why a huge pressurized pool of bubbling magma gathers at a depth of only several miles. The pressure keeps growing because more magma is trying to get to the surface, until, bam, a super eruption occurs. The most recent super eruption happened in New Zealand. Well, when I say recent, I mean around 26,500 years ago. Nah, I wasn't around then. That's when a supervolcano beneath the surface of Lake Tahoe spewed into the air more than 300 cubic miles of ash and pumice. Imagine 500,000 Great Pyramids of Giza flying up at the same time. That's how incredibly powerful that eruption was. But the most exciting and confusing thing about the eruption was that the Tahoe volcano simply didn't go off like many others. At first, everything was going as usual. More than 200 square miles of magma had built up under the surface, and the pressure was getting higher and higher. But after the rock cracked and the first part of lava rushed out of the crater, something went wrong, and the supervolcano took a break. Only several months later, the disastrous eruption shook the ground, and thousands of tons of lava, rocks, and ash flew high into the atmosphere. But the age of supervolcanoes isn't over. The most infamous of them all is probably the one in Yellowstone National Park. This giant handles at least 3 mega-powerful eruptions, and who knows how many smaller ones. If this monster erupted anywhere as strongly as it did 2.1 million years ago, it would spit out more than 588 cubic miles of red-hot material. You can probably picture it more vividly if I tell you that this volume is comparable to 65 million Capitol rotundas in Washington, D.C. piled together. Wow. Anyway, scientists are sure that Yellowstone doesn't present any danger these days. For an eruption to happen, magma inside must be at least 50% molten. With the Yellowstone caldera, this number is just 5 to 15%. But of course, Yellowstone isn't the only supervolcano on our planet. There's also New Zealand's Tahoe you already know about, Japan's Eri Caldera, California's Long Valley, Indonesia's Toba. Any of them can one day produce a super eruption. There are also several so-called supervolcanoes that haven't lived up to this name yet because they've never produced anything like a super eruption. For example, in 1883, Indonesian volcano Krakatoa went off. The power of the eruption tore the volcano's walls open, and cold seawater rushed into its molten insides. The difference in temperature made the volcano blow up with a deafening boom. It was clearly heard 2,000 miles away in Australia. It earned the blast the title of the loudest sound in history. But even though the consequences of this event were truly catastrophic, it still turned out not powerful enough to be called a super eruption. Kilauea, one of the most active volcanoes in the world, erupted again in March 2026 on Hawaii's Big Island. Huge lava fountains shot into the sky. The main highway was closed, and the airport was blocked by sandpaper clouds of ash. The sky turned a creepy deep red. That's how thick the smoke was. The eruption literally closed some areas of the island. It was already the second time this year. The eruption happened right inside the Halemu'umu'u crater at the volcano summit. Things got dangerous fast, and visitors had to evacuate the volcano summit. The lava fountain shot straight up about 1,300 feet. That's almost as tall as the Empire State Building or higher than the Eiffel Tower. But let's watch the eruption unfold step by step. It started on March 10, 2026, and lasted about 9 hours. ending suddenly at 6:21 p.m. The eruption started in the morning at 9:17, with lava shooting up from the north vent. As for the south vent, it started erupting just before 10 a.m. By early afternoon, the lava fountains were huge. The south vent reached 1,150 feet high, and the north vent was 1,000 feet. The lava was flowing across about 1/3 of the crater floor, glowing bright orange and red. As the lava cooled in the air, it turned into something called tephra. It's a mix of volcanic rock, ash, and tiny glassy shards. Tephra can scratch your skin like sandpaper, making your eyes sting and making it hard to breathe. Even worse, it can turn roads into skating rinks for cars. Because all of this, part of Highway 11 was closed between mile markers 24 and 40. Back in January, during another eruption, it also rained tephra over the park and nearby towns. Some unlucky visitors actually got hit by falling tephra, and a few even got cuts. The Park Service had to close the summit for the first time since its eruption cycle began on December 23, 2024. Now, the National Weather Service says the eruption plume reached 25,000 feet high. That's nearly 5 miles straight up, higher than most airplanes fly. Winds were blowing from the south, so ash and gas started moving north from Halemaumau. Officials warned people in nearby cities to stay indoors or leave if the gases began to bother them. Now, this eruption wasn't the first trouble Kilauea caused this year. An earlier one started on February 15th and lasted almost 10 hours. During that eruption, lava covered half of the crater floor. Scientists estimate that 15 million cubic yards of lava came out. That's enough to fill thousands of swimming pools or cover hundreds of football fields. At 2 p.m. on March 10th, tephra was still falling. Park rangers helped evacuate visitors from the summit. All trails and viewing spots near the summit were closed. Scientists are keeping an eye on things all day and night, watching how high the lava shoots, how fast it flows, which way the ash cloud is moving, and where the fallout spreads. Even though the lava mostly stays in the crater, tephra and volcanic gases can make living near a volcano pretty risky. Since December 24, 2024, Kilauea has been spitting lava on and off, mostly from 2 vents at the summit crater, one to the north, one to the south. Eruptions happen in short bursts, usually less than half a day. After that, the volcano takes a break for a while. Could we say the volcano is chilling? No, we can't. Sometimes those pauses can last 2 weeks or more, as if giving the lava time to catch its breath before the next show. But let's talk a little bit more about tephra. The biggest problem is that it doesn't just stay near the volcano. In past eruptions, it rained down on neighborhoods as far away as Hilo and Puna, messing up water systems and creating a huge cleanup job. At Hilo International Airport, all evening flights were canceled because of ash in the air. And for weeks afterward, locals and park staff were sweeping tephra off roofs, gutters, streets, just about everywhere you can imagine. According to the park spokesman, the reason tephra spread so far is a mix of weak winds and extremely tall lava fountains. When that happens, the volcanic debris drops straight down over the park and nearby towns. During past eruptions, steady winds, called trade winds, which usually blow from east to west across the islands, acted like a conveyor belt. They carried ash and volcanic gases over the Cow Desert and nearby towns to the southwest. Another super dangerous thing about an eruption is glass rain, also called Pele's hair. It's a kind of tephra that happens especially when lava fountains shoot up really fast. Tiny gas bubbles in the lava burst and stretch the molten rock into super thin, fragile strands. The wind then carries them far away. This stuff is lightweight but brittle, so it can scratch your skin or get in your eyes or lungs. The name comes from Pele, the Hawaiian goddess of fire and volcanoes, because it's kind of born straight from volcanic activity. During big eruptions, like the one in 2018, these strands were reported falling all around the volcano. Now, Kilauea isn't the only threat in the region. The sleeping giant next door, Mauna Loa, got an update from scientists on March 5, 2016. The volcano isn't erupting yet, but it's inflating as magma fills its huge underground chambers. You might think of it like Earth taking a deep breath. But it isn't just breathing. In the past month alone, over 100 earthquakes have been detected under the summit. Should we get worried? Well, let's figure it out. Mauna Loa, the largest active volcano on Earth, covers half of Hawaii's Big Island. Its eruptions can produce huge, fast-moving rivers of lava, like a slow-mo bulldozer made of molten rock moving across the area. When Mauna Loa erupts, it usually starts at the summit. From there, lava can flow into different areas: the Northeast Rift Zone, Southwest Rift Zone, or even vents on the northwest side of the volcano. The most intriguing thing is that these lava flows can appear within minutes, hours, or even months after the eruption begins. Since its first well-recorded eruption in 1843, Mauna Loa has erupted 34 times. The gaps between eruptions can range from just months to many decades. Its most recent eruption was in 2022. Right now, Mauna Loa is quiet but active. Seismic activity, that is, small earthquakes under the volcano, shows that magma is, in fact, moving beneath the surface. In February 2026, scientists detected 116 earthquakes beneath the summit, mostly gathered under the caldera era called Makuaweo Veo. Some were also concentrated in the southern caldera. But don't let this number scare you. For comparison, the month before had 123 earthquakes. The thing is, these quakes are part of the normal breathing of the volcano as it refills with magma after the 2022 eruption. GPS instruments on the volcano indeed show that the summit is inflating, meaning the ground is slowly rising as magma fills the underground reservoir. At the same time, gas and temperature readings from the Southwest Rift Zone are at normal levels, which means no major changes compared to previous months. So even though Mauna Loa is refilling, there's no immediate sign of a new eruption, yet. In any case, Mauna Loa is always worth watching. It's a sleeping giant that can wake at any time, and scientists are keeping a close eye on every inch of rising ground. Because if Mauna Loa erupts, it can cause a ton of different problems. Massive rivers of lava can flow quickly and cover land in their path. The volcano itself can also make the ground shake, because as magma fills it, the sides of the mountain can shift up or sideways, triggering earthquakes. On top of that, Mauna Loa can release volcanic gases that mix with the air and create fog, a kind of smog that can be irritating or even make it hard to breathe for people living downwind. Sometimes, the volcano might even produce small explosions, sending ash into the sky, which can be dangerous for airplanes flying nearby.
Stop for a second and look at the ground beneath your feet. Is it a quiet suburban street, a flat basketball court, or maybe a peaceful stretch of farmland? You probably feel safe because there isn't a giant smoking mountain on the horizon, but that safety is an illusion. Yeah, sure. Yellowstone, Vesuvius, or Mount Fuji, those are the celebrities of the geological world. Giants that dominate the skyline and sometimes blow their tops. But what about a hidden threat? One that doesn't look like a volcano at all. It's invisible, it's silent, and thousands of these traps are scattered across the planet, lurking right under the foundations of our biggest cities. Scientists call them monogenetic volcanic fields. To the untrained eye, they don't look like volcanoes at all. They disguise themselves as innocent hills, flat plains, or just lovely lakes. For decades, they were mainly ignored because of their small size. But new data suggests these hidden systems are far more dangerous than previously thought. And unlike the big giants that give weeks of warning rumbles, these invisible volcanoes specialize in surprise attacks. Hold tight. To understand the danger, we have to look at the plumbing. A standard volcano acts like a simple chimney. There is a central magma chamber and a main pipe leading to the surface. Eruption after eruption, lava flows out the same vent, building a massive cone over thousands of years. Monogenetic fields break all these rules. They don't build mountains. They don't reuse the same pipe. Instead of a chimney, imagine a cracked windshield. Magma deep underground scans for any weakness in the crust over a massive area. It pushes up, cracks the surface, erupts once, usually violently, and then calms down forever. The next time magma rises, it won't use that old vent. It will find a new crack 5 miles away, or 10. This means you can't just monitor one specific mountain. The entire region is a danger zone. And because each volcano is a one-and-done event, the landscape is deceptive. You could drive past the site of a violent ancient explosion every day on your way to work and simply see a grassy knoll. The scary part is the speed. In these fields, magma can rocket from 30 miles down to the surface in less than 24 hours. It moves at a speed of up to 4 miles per hour. That sounds slow for a car, but for melting rocks, that is the speed of an elevator. This isn't just a theoretical problem for empty deserts. Take Auckland, New Zealand. It's a stunning modern city with beautiful harbors and over 1 million residents. But Auckland is built directly on top of a geological minefield. Sounds a bit crazy, right? Beneath rugby stadiums, parks, and busy intersections lies the Auckland Volcanic Field. Those scenic green hills scattered across the city aren't just landscaping. They're the remains of over 53 separate volcanic eruptions. Rangitoto Island, which sits just offshore, emerged from the ocean only 600 years ago. In geological time, that was 5 minutes ago. For years, this field was considered sleepy, but recently, scientists have started noticing subtle changes. The terrifying reality of a field like this isn't that a volcano we already know will erupt again. It's that a new one can pop up and go from zero to a disaster in the blink of an eye. A bubble of magma could rise silently beneath a factory, a highway interchange, or a residential neighborhood. There is no designated safe zone because the threat is spread across the entire city map. History gives us a brutal example of how fast this happens. In 1943, a farmer named Dionisio Pulido was plowing his cornfield in Mexico, on the outskirts of Mexico City. It was a normal Tuesday. Suddenly, the ground cracked open right in front of him. Smoke hissed out, smelling of rotten eggs. Within 24 hours, that small crack in a flat field had transformed into a raging volcano 160 feet tall. Within a week, it stood 500 feet high. This was the birth of Parikutin. It wiped out 2 entire towns, leaving only the stone steeple of a church poking out of the hardened lava, a haunting monument that still stands today. This geological nightmare started in a simple cornfield, and it wasn't an isolated incident. Look at the Harat Rahat field in Saudi Arabia. In 1256, a massive fissure opened up near the city of Medina. It spewed lava for 52 days, creating a river of fire 14 miles long. Today, that same volcanic field is still there, and modern Medina has expanded right on top of the ancient lava flows. Now, apply that same story to a suburb of Los Angeles, a district in Tokyo, or a neighborhood in Europe. In a matter of days, an entire city can be buried under ash. The risk is global, ranging from over 1,800 vents in the American Southwest to the restless Eifel region in Germany and similar fields in China. Experts warn that the real risk here isn't size, but frequency and location. These volcanoes tend to be explosive. When magma rises rapidly and hits groundwater, which is common under cities and fertile farmland, it flashes into steam. This creates a phreatomagnetic explosion. Instead of a slow, oozing river of lava that people can walk away from, the ground acts like a shotgun blast. It sends a massive column of ash and rock shooting into the atmosphere. In our modern world, this is a recipe for chaos. We rely on delicate systems, air travel, GPS signals, just-in-time supply chains. You don't need a supervolcano to crash the global economy. A small eruption near a major logistics hub is enough. Remember the 2010 eruption in Iceland? That wasn't even a big explosion by historical standards. Yet, the ash cloud grounded over 100,000 flights, and 10 million passengers were stranded. Volcanic ash melts inside jet engines, while toxic dust poisons crops and contaminates water reservoirs with heavy metals. It creates a domino effect. One small eruption in the wrong place triggers a cascading failure of global infrastructure. And the most alarming part is that the signals are already there. Recent geological studies have shown an uptick in activity in these distributed fields. It isn't always violent earthquakes. Often, it's bradyseism, the slow rhythmic breathing of the ground. We mentioned the Eifel region of Germany, where GPS data shows the land is rising by about 0.04 inches per year. It sounds tiny, but for geologists, that is a proper red flag. Scientists are detecting slight swells in the Earth's crust and weird spikes in carbon dioxide emissions in places that should be quiet. Magma is moving, but because these systems are so spread out, monitoring them is a nightmare. We have sensors all over Yellowstone. We watch Vesuvius 24/7, but almost no one is watching a random patch of desert in Arizona or a forest floor in Germany. These invisible volcanoes are poorly studied. We lack the baseline data to know if a tremor is just a truck driving by or the start of a Pericotine-style event. This lack of data means that when an eruption starts, authorities might have almost zero warning. In a polygenetic volcano, the mountain swells for months. In a monogenetic field, magma can shoot from the deep mantle to the surface in hours. By the time the evacuation order is written, the lava could already be breaking through the pavement. It isn't that hard to imagine the logistical nightmare. A city not known for volcanoes suddenly receives an alert. A vent is forming downtown. It sounds impossible. People delay leaving. They grab their phones to film the smoke. Then, explosions start. The ash creates a blackout. Power grids fail as wet ash shorts out transformers. Roads gridlock instantly. This scenario isn't science fiction. It's exactly what hazard models predict for places like the Auckland Volcanic Field or parts of the Trans-Mexican Volcanic Belt. We are building denser and denser cities on top of geological landmines. This doesn't mean we need to start digging bunkers, but it does require a shift in perspective. We have spent so much time worrying about the celebrity volcanoes that we forgot about the quiet ones. The Earth is a living, shifting engine that doesn't care about property lines or city limits. Scientists are now pushing for better monitoring networks, using satellites to track even the tiniest ground deformation in these boring, flat fields. Because the only way to survive a surprise attack is to see it coming before the ground cracks open. Peace and quiet on the surface doesn't always mean peace and quiet underneath. The Earth has plenty of secrets left, and some of them are just waiting for the right moment to surface. You're in Italy, perfect sun, perfect pizza, but enjoying that view, it might be a fatal mistake. That peace is a total illusion. Literally a few miles beneath your sneakers, the Earth isn't just sleeping, it's taking a deep, nervous breath. And I mean it. Geologists are sweating right now because this hidden process isn't just happening, it's accelerating fast. When most people think about volcanoes in Italy, they think about Mount Vesuvius and that tragic story of the ancient city of Pompeii. Ash falling from the sky, a city frozen in time, a tall volcano standing over the Bay of Naples. Vesuvius looks dangerous, and it makes sense that people focus on it. But Vesuvius is not the biggest threat in the area. The real danger is harder to see. Just west of Naples is an area called Campi Flegrei. The name means burning fields. If you visit, it doesn't look like a volcano at all. There's no mountain, no cone, no rivers of lava. Instead, you see towns, ports, roads, and neighborhoods. People live their everyday lives there. That's because Campi Flegrei is not a normal volcano. It's a supervolcano. Forget the classic pointy mountain. Regular volcanoes build up, but supervolcanoes blow down. They leave behind a massive bowl-shaped depression called a caldera. Campi Flegrei is so vast you could stand right in the center and never realize you're on top of a volcano. In fact, a huge chunk of Naples is built right inside it. Can you picture this? Homes, schools, and highways sit on ground that is still active. It's like a giant chest taking a breath, rising and falling. Scientists call this bradyseism. Entire neighborhoods have shifted up or down by feet over the centuries. But how? That rhythm is changing fast. Around 2022, scientists started paying much closer attention to the area. Seismic activity was increasing, and new tools made it possible to look at the data in better ways. Researchers gathered records of more than 54,000 earthquakes. Most of them were small. Many were too weak for people to even feel. When all of that data was put on a map, it looked like chaos. Thousands of tiny dots spread everywhere with no clear pattern. To the human eye, it was just noise. Too much information to make sense of. So scientists turned to machine learning. Instead of looking at each quake one by one, AI models were used to scan the entire dataset at once. The goal wasn't to predict an eruption, it was to see how stress was moving underground. That's when something new showed up. Hidden inside all that messy data was a large circular fault system, a ring-shaped crack in the Earth's crust that outlined the edge of the caldera. It had always been there, but it was buried in the noise. Once the AI pulled it out, it changed how scientists understood the whole system. This kind of ring fault matters a lot. It acts like a pathway. Pressure from deep underground, magma, hot water, and volcanic gases can move along it more easily than through solid rock. Instead of pressure spreading out evenly, it gets focused along this ring. That alone would be concerning, but the story doesn't stop there. The new study uncovered something scary under Pozzuoli. The city is sitting on a crossroads of deep cracks in the earth, including the newly discovered ring fault. Scientists used to think this area was low risk, but the new numbers tell a different story. Pozzuoli sits on the weakest spot of the whole system. Since the rock is already so broken up underground, the pressure has an easy way out. That means when the magma chamber breathes, this city takes the hardest hit. Residents aren't just neighbors to the volcano, they're sitting right on top of the exhaust pipe. Based on this new data, scientists are saying that magnitude 5 earthquakes are not just possible, they're likely. To many people, that number doesn't sound all that scary. We see headlines about magnitude 7s and 8s in the Pacific all the time. But Campi Flegrei plays a completely different set of rules. The danger here isn't just the size of the quake, it's the location. In places like Tokyo, quakes are usually deep, so by the time the waves reach you, they feel like a rolling motion. But here, earthquakes are incredibly shallow, sometimes starting just a few thousand feet below the pavement. That makes a huge difference, because the explosion is happening right under your feet. The ground doesn't roll, it jolts hard. It's a violent vertical kick that amplifies the damage. Even a small quake here hits with the intensity of a truck crash. And that kind of force is bad news, also because of the buildings. Many structures in this area are old, historic treasures, sure, but dangerous. They were built centuries before modern seismic safety codes were even a concept. We're talking about things that were never designed to move. Thick stone walls, aging water pipes, and rusted gas lines. None of this handles shaking very well. Modern steel bends. These old stones just crack. All of this destruction is driven by a phenomenon called bradyseism. Think of it as a massive hydraulic system operating deep underground. Miles below the surface, a volatile mix of magma, superheated fluids, and volcanic gases are constantly trapped. Over time, that cocktail builds up immense pressure. As the pressure grows, it pushes against the crust, literally lifting the ground and the entire city upward. When the gas escapes or the pressure drops, the ground sinks back down. It's a slow, relentless cycle of rising and falling. And this isn't just a scientific theory. We have clear physical proof. In Pozzuoli, there's an ancient Roman building called the Temple of Serapis. Its stone columns are marked with holes made by sea creatures that only live underwater. Those holes show that the building once sank below sea level and stayed there for a long time. Later, it rose back up again. The ground didn't move suddenly, it moved slowly, over centuries. The earth here has always been unstable, slowly breathing in and out. What scares scientists today is how fast the movement is happening now. Since April 2025, the ground has pushed up 0.6 inches every single month. That doesn't sound like much, but in geology, that's fast. Over a year, it adds up to nearly 7 inches. Buildings are not designed to move like that. As the ground lifts, foundations get stressed, pipes stretch, roads bend. At the same time, the ring fault is being pulled tighter and tighter. Systems under stress don't always fail slowly. Sometimes they break all at once. It wouldn't take a huge event to push things over the edge. A small shift in magma, a sudden release of gas. Something like that could trigger stronger earthquakes. If that scenario plays out, we're not talking about some cracked plaster or a few broken windows. It hits the panic button for the entire red zone. And let's be real, evacuating Naples isn't just hard. It's a logistical nightmare straight out of a disaster movie. We're talking about a critical red zone holding 500,000 people, from Pozzuoli to western Naples, who would have to evacuate the second the alarm sounded. And right next door is the yellow zone, where another 800,000 residents are sitting directly in the path of choking volcanic ash. These are narrow, winding, ancient streets built for donkeys and carts, not for 500,000 panic-stricken people trying to leave at the same time. It's a recipe for absolute gridlock. We're talking bumper-to-bumper traffic where nobody moves an inch. Then there's the money. The economic hit would be staggering. Overnight, one of the most vibrant places on Earth turns into a ghost town. No tourism, shops boarded up, businesses wiped out. The ripple effect wouldn't stop at the Italian border. It would hit the whole European economy. Now, sure, this isn't ancient Pompeii. We have satellites and smartphones. We aren't totally blind. So hey, apparently, there's absolutely no need to be worried, right? It's official. We now know the exact location and timing of the Yellowstone supervolcano's next eruption, and it's called a supervolcano for a reason. It will be thousands of times more powerful than a typical volcanic eruption. When this happens, the planet will face massive disasters. Earthquakes, tons of magma flows, ashen clouds that will block out the sun. The sky will be gray for a long time. We will have a shortage of food because of the lack of sunlight. Planes won't be able to fly. Some species of animals and trees may disappear. One disaster will follow another like falling dominoes, one by one. Terrible times await Earth and… okay, stop. It's clear, we got it. But when will all this happen? Don't worry, you won't be left without an answer. When ordinary volcanoes erupt, it's always a disaster, but only for those places that are located near the epicenter. Multiply the damage from an ordinary volcano by thousands and you'll get a supervolcano eruption. Yellowstone is one of the largest volcanic systems in the world. It's erupted 3 times in the last 2.1 million years. The last time was 640,000 years ago. The ash covered an area comparable to about half of the United States. Fortunately, there were no people there, but nature got hurt. A similar eruption of a similar supervolcano occurred about 74,000 years ago. It was the Toba supervolcano in Indonesia that caused an apocalypse the human race barely managed to survive. According to some theories, only a few thousand people stayed alive at the time during the volcanic winter, but it's not confirmed. Since Yellowstone is a volcanic system located in a vast national park, it was important for scientists to find out exactly where the first spark would come from. They found out that Yellowstone's magma doesn't accumulate in one place, but hides in several separate underground reservoirs. The reservoir in the northeast of Yellowstone, next to a beautiful place called Sour Creek Dome, is the riskiest. Here, the red-hot magma comes into contact with the hot rocks of the mantle, which are located deep in the ground. Their high temperature keeps the magma in a liquid state. Imagine that you put a pot of hot milk on the stove. Nothing cools down, but only gets hotter, so the milk may soon begin to rise and flow out of the pan. The same thing is happening with the magma under Sour Creek Dome. Magma doesn't cool down there, and at some point it may start to come out. It'll be like a broken pipe from which a fountain of boiling water gushes. But how did scientists find out? The magma reservoirs are located at a depth of about 6 miles, and this whole area is incredibly hot. They used a special method called magnetotellurics. So, Earth's rotating core creates a magnetic field that surrounds our planet. Magma flows around the core, and it contains many magnetic minerals that also create magnetic fields. Scientists use special instruments that sense those fields emanating from the magma, like a metal detector senses lost jewelry on the beach. Using magnetotellurics, they scanned Yellowstone and discovered 4 large magma reservoirs. 3 of them emitted powerful electromagnetic waves, and in the 4th, which is in the northeast, they recorded a much stronger signal from the magnetic field. This is where the eruption is supposed to occur. But fortunately, it won't happen soon. Perhaps in tens of thousands of years, perhaps in hundreds. Phew, you can relax. No volcanic apocalypse is coming soon. But how do scientists know when this magma will start to erupt? Magma doesn't have a timer, and the volcano doesn't wake up with an alarm clock. So, magma flows inside the pores of solid rock. It resembles a dishwashing sponge with lots of small holes through which water passes. Magma penetrates these pores and fills them. For magma to start erupting outward, it must fill at least 40% of these pores. About 20% of them are filled now. But these hot rocks continue to heat the magma and keep it liquid, so it can flow between the pores. At some point, it will connect with other pools of the liquid magma and become a large stream that will rise to the top. How can we prevent this from happening? It seems that the solution here is to cool the balsam rocks, but it's impossible to do so. They are several miles deep, they are incandescent, and there are too many of them. And in any case, trying to cool a part of the Earth's core sounds like a very bad idea. All we can do is accept that nature has its own plans. If the eruption occurs in tens or hundreds of thousands of years, then perhaps humanity will find a way to solve this problem. If not, then we should prepare for the consequences. A huge global catastrophe starts with a massive, large-scale explosion. The erupting magma produces a gigantic amount of ash. A powerful burst of energy collapses the Earth's crust over the magma reservoir. This leads to the formation of a giant caldera. You've probably seen a huge crater in a volcano. So, this is the caldera. The natural disaster is so loud it deafens everyone who's nearby. The blast wave rises ash and pumice stone at a speed exceeding the speed of sound. Volcanic materials reach incredibly high altitudes in minutes. Then, this pillar of ash spreads and plunges a huge territory into darkness. The incandescent particles in the lower part fall under their own weight and heat the air around them. It's almost impossible to breathe. The red-hot pieces of pumice stone and ash set fire to the surroundings. All this hot mass turns into pyroclastic flows that destroy and burn everything in their path. Forests, houses, roads, everything turns into coal. No planes can fly there. Tiny particles can penetrate engines. Besides, it's impossible to see through such a dark gray, hot cloud. It's also dangerous to drive cars. Volcanic particles can burn tires. Luckily, thanks to seismic technologies, people have learned in advance about the eruption, so everybody has evacuated. The column of ash that has reached the edge of space continues to expand in different directions. The wind helps the volcanic dust expand. A giant umbrella-like cloud appears over the territory of Yellowstone. It's getting wider and wider and plunges a huge area into hot darkness. During the first 24 hours, ash falls on most of the United States and parts of Canada. It knocks out power lines, pollutes bodies of water, and destroys crops. Then, the rains begin. The water mixes with the ash and falls to the ground in the form of gray mud. And don't forget, it's also poisonous. The ash contains mercury, arsenic, and lead in large quantities. Such toxic masses poison rivers, lakes, land, and air. All this time, the volcano continues to erupt. The outbursts of magma, ash, and pumice can last for several weeks or even a month. And this is just the beginning. The ash soon begins to settle, but the sulfur dioxide released during the eruption spreads all over the atmosphere. This gas mixes with the atmospheric water vapor and forms an aerosol consisting of small particles. All this covers the planet like a veil. This cap makes it difficult for the sun's rays to pass through, which means it lowers the temperature of the Earth's surface. These events cause a sharp cooling of several degrees in the world. Farmers lose a huge amount of their crops. Food prices rise and economies collapse. There might be a famine all over the planet. human civilization can plunge into chaos. In a few years, the temperature will start rising, but it will take at least a couple of decades to return to previous standards. What will become of humanity by that time? Of course, we will survive, but we'll have to rebuild our civilization. But don't be afraid. If nothing depends on us, let's just enjoy every day of life, be grateful, and help each other. Supporting and caring for each other even during the volcanic winter is a guarantee that humanity will survive.
Frankenstein, unreasonably cold weather, and tons of lava. What do these things have in common? They all trace their origins back to Mount Tambora. This volcano in Indonesia had such a massive impact that the aftermath could be felt in Switzerland even a year later. And these spots are thousands of miles apart. Soon, we might be facing something similar again. Stick around because I'm about to reveal the exact spot where the next eruption is expected to happen in 2025. Back in 1815, Mount Tambora erupted with unprecedented force, sending a colossal cloud of fine particles into the atmosphere. This cloud reflected sunlight, leading to global cooling and even the year without a summer in 1816. Temperatures plummeted, crops failed, and families worldwide faced food shortages, compounded by various health issues. Fun fact: Frankenstein appeared because of abnormally cold weather in the summer of 1816. The author got stuck indoors in Switzerland and wrote this story to pass the time. But that is the only positive aftermath. In England and Ireland, people struggled to find food. The crops were too bad that year, and this year without summer cost them lives, all because of the eruption in Indonesia. While many other volcanoes have erupted since then, none have had consequences as dramatic as Tambora. However, climate professor Marcus Stoffel from the University of Geneva believes potential serious eruptions aren't just a matter of luck, it's only a matter of time. So it's up to us. We can sit back and wait for the inevitable, or we can start preparing today. This future eruption will happen in a world that's vastly different from the one in 1815. Not only is our planet more densely populated now, but we've also experienced irreversible changes that affect our daily lives. Now, if you think volcanoes are always the bad guys, think again. They've actually played a crucial role in shaping our planet. They help with land formation, atmospheric development, and climate modulation. Just look at Yellowstone, for example. When thick lava oozed to the surface, it spread across the landscape and transformed the area forever. When volcanoes blow their tops, they release a mix of lava, ash, and gases, including carbon dioxide. But don't worry, compared to the emissions from fossil fuels, the amount from volcanoes is pretty tiny. What scientists are really keeping an eye on is sulfur dioxide, because it can have a big impact on our climate. When a major volcanic eruption happens, it can send sulfur dioxide soaring into the stratosphere, which is about 7 miles up in the atmosphere. Once there, it transforms into tiny aerosol particles that scatter sunlight, helping to cool the planet. This cooling effect isn't immediate though. Those particles can hang around for a couple of years and even circulate all around the globe. Nowadays, we've got special equipment to monitor sulfur dioxide emissions from space. Take Mount Pinatubo in the Philippines. During its eruption in 1991, it released around 15 million tons of sulfur dioxide. Now, while that's a lot, it wasn't quite as massive as the eruption of Tambora. Still, Pinatubo managed to lower global temperatures by about 0.5 degrees Celsius for several years. Tambora, on the other hand, dropped average global temperatures by about 1 degree Fahrenheit. I know what you might be thinking. That's not much, but trust me, it makes a difference. If the planet warms up by just 1 degree Fahrenheit, it could really mess with sea levels. Experts think we might see a rise of up to 8 inches by the end of this century. This could wipe out a lot of farmland and coastal habitats, which would be a huge blow to many communities. So maybe a volcano eruption that can cool off the planet is like a natural mechanism helping us out? Not exactly. While it does cool the planet off, don't get tricked into thinking it's the kind of coolness our planet needs. Such temperature shifts can severely mess up with the crops, like they did in 1816. There's also evidence that major eruptions can disrupt rainfall patterns, leading to drier conditions in monsoon regions across Africa and Asia. You see, the summer monsoon relies on the temperature difference between land and ocean, which can be altered by volcanic activity. Interestingly, a warmer climate may enhance the cooling effects of volcanic eruptions. Experts explain that the formation and movement of aerosol particles depend on climate conditions. As global temperatures rise, faster air circulation can lead to smaller aerosol particles, which are more effective at scattering sunlight and thereby intensifying the cooling effect. Oceans also contribute to this dynamic. A warming ocean surface creates a stratified layer, hindering the mixing of warm and cold water, which could mean that volcanic eruptions primarily cool the upper ocean layer and the atmosphere above it, according to Stoffel. Moreover, climate change may influence volcanic systems directly. The melting of ice can trigger more eruptions by reducing the pressure that allows magma to ascend more easily. Additionally, increased rainfall associated with climate change can seep into the ground and interact with magma, potentially sparking eruptions. While the prospect of a cooling period due to a volcanic eruption might seem beneficial amid climate change, scientists warn that the effects could be dire. The immediate consequences could be severe, particularly for the estimated 800 million individuals residing near active volcanoes. A major eruption could devastate entire cities. For example, Campi Flegrei, located near Naples, Italy, is showing signs of increased activity and threatens the lives of about 1 million people. Now, if you're from Oregon, beware, as experts say this state might experience volcano eruptions. Are you scared? Don't be. It's actually not as scary as it seems. Let me explain why. There are more than 80 volcanoes in Oregon, but we're not interested in a single one of them because it's an underwater volcano that is likely to erupt in 2025. Axial Seamount is the most active volcano in the Pacific Northwest, yet it remains largely unknown to the public due to its location approximately 300 miles offshore and nearly a mile beneath the ocean's surface. While its upcoming eruption is expected to pose no threat of a tsunami or significant land-based earthquakes because of its depth and distance from the Cascadia Fault, the data gathered from studying its eruptions can enhance our monitoring of potentially more hazardous volcanoes. Let's call it a friendly eruption, shall we? In reality, predicting eruptions is a complex endeavor. We often encounter alarming headlines, such as, "Yellowstone is about to erupt." Should we take these claims seriously? Not really. Yes, Yellowstone sits atop an active supervolcano that has experienced 3 major explosive eruptions in the past 2.1 million years. The last eruption occurred approximately 70,000 years ago, with the most significant explosion taking place around 631,000 years ago, forming the massive Yellowstone caldera. Naturally, many people are curious about whether Yellowstone will erupt again and when that might happen. Fortunately, scientists are employing new techniques to delve into these questions. A recent study suggests that Yellowstone is unlikely to experience another major eruption anytime soon. The reason is that the magma beneath the park is divided into a network of separate chambers. While there is a substantial amount of magma present, it's not sufficiently interconnected to support an eruption. Previous studies proposed that the existence of a massive layer of magma beneath Yellowstone, but these latest findings change that notion. To gain a clearer understanding of the subterranean dynamics, researchers utilized a technique called magnetotellurics, which employs Earth's natural electromagnetic fields rather than seismic waves. Since magma is a good conductor of electricity, this method is particularly effective for mapping molten rock and comprehending underground activity in volcanically active regions. By using magnetotellurics, scientists created a detailed map of the magma under Yellowstone enabling them to make more informed predictions about future eruptions. But what will happen if an eruption similar to Mount Tambora occurs? By and large, there will be huge climate chaos. Yeah, the best scientists are looking for the solution should it really happen, but they don't have it yet. So technically, we're not ready for the second Mount Tambora. But for now, we're pretty much safe. No major eruptions are predicted. Whew! At the end of December 2021, an underwater volcano with a rather exotic name, Hunga Tonga, woke up after several years of sleeping. It did that with so much energy and strength that people heard the eruption from over 100 miles away. Then it went back to sleep. But a couple of weeks later, it woke up again with a force 7 times greater than the first time. It broke the island above it in 2 parts. The lightning storm that started because of the eruption was the most intense in recorded history. The sound waves from the eruption traveled around the planet several times. Someone even heard a loud boom from it in Alaska. And it started the first known mega tsunami since ancient times. This tsunami took the lives of 2 people as far as Peru and caused trouble for 2 fishermen in California. But that's not all. This eruption could change the weather patterns on Earth for years. You may see the first proof in the summer of 2024, which is forecast to become much wetter than usual. Scientists believe the eruption was caused by gas building up to a critical point. Different minerals, including anhydrite quartz and sulfides, were building up for several months until they blocked the flow paths and sealed the gas within Hunga Tonga. Normally, when a volcano erupts, the fumes cause a temporary cooling effect on Earth's surface. But Hunga Tonga's eruption was different. It didn't produce much fumes, but released a massive amount of water vapor, roughly equal to 60,000 Olympic swimming pools. The intense heat of the eruption turned huge amounts of seawater into steam, which then blasted high into the atmosphere. All that water vapor ended up in the stratosphere, a layer of the atmosphere that's too dry to form clouds or rain. Scientists don't have any observations of volcanic eruptions like Hunga Tonga to predict its effects on our weather patterns. They can't tell exactly how long these effects might last either. This is because the only way to measure stratospheric water vapor is with satellites, which have only been around since 1979, and there hasn't been an eruption similar to Hunga Tonga in that time. Experts from different countries started analyzing satellite data right after the Hunga Tonga eruption. They wanted to find out how long water vapor would stay in the stratosphere, where it would go, and, most importantly, what this would mean for the planet. The first big result of the eruption, at least partially, was a huge hole in the stratosphere that was hanging on for several months in 2023. By the time it appeared, the water vapor had reached the polar stratosphere over Antarctica. In the following years, there wouldn't be enough water vapor left to enlarge this hole. It looks like Hunga Tonga will have just a minimal effect on global average temperatures. But there are some surprising, lasting regional impacts. One of the scientific models forecasts colder and wetter winters for northern Australia until about 2029. In North America, it predicts warmer winters, and Scandinavia could have even colder winters. This is just one study though, and one approach to understanding how the eruption of Hunga Tonga can change our weather. We do have at least one example from history when a volcano eruption changed the world. Over 2 centuries ago, in 1815, Mount Tambora erupted and caused the year without a summer. In the following year, the winter was unusually cold and wet weather across Europe and North America. A recent study confirms that 1816 wouldn't have been this cold without the volcanic eruption. The immediate effects of the eruption were catastrophic, with tsunamis destroying homes, claiming 10,000 lives, and 80,000 more who fell ill in the aftermath. The eruption of Mount Tambora was one of the strongest in the last 1,000 years. It had ejected an enormous amount of sulfur dioxide into the stratosphere, which quickly spread across the world. It resulted in the coldest year in at least the last 250 years. In May, frost wiped out most of the crops in New York, Massachusetts, New Hampshire, and Vermont. By June, heavy snow covered the ground in Albany, New York, and Dennisville, Maine, and New Jersey had 5 straight nights of frost. The cold continued into late summer, which should have been the harvest season. In July, lakes and rivers were still frozen as far south as northwestern Pennsylvania, and frost stayed in Virginia until late August. Temperatures would drop from above normal summer highs to near freezing within just a few hours. The weather was completely unpredictable. Prices of food skyrocketed. The cost of oats for horses, which were the main mode of transportation, also rose sharply. Some people believe this situation inspired Carl Drees to invent the bicycle in 1817 as an alternative transportation method. Tambora changed weather patterns completely for not just 1, but 3 years. The whole planet got colder, and as crops failed, probably at least 1 million people starved. Scientists don't have solid evidence of volcano eruptions that have taken more lives than Tambora. But the Krakatoa eruption in Indonesia in 1883 is far more famous than Tambora because information about it spread worldwide via telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami with waves about half as tall as the Statue of Liberty. Still, it was less powerful than Tambora's eruption. The island that once hosted Krakatoa disappeared in the eruption, but new eruptions began less than 50 years later and created the Child of Krakatau cone in the center of the caldera of the old eruption. The new volcano still comes to life from time to time. Mount Vesuvius's eruption, which took down Pompeii, is one of the most well-known volcanic disasters in history. It took around 2,000 lives, much fewer than Tambora. According to a famous Roman author of that time, the eruption lasted 18 hours. Pompeii was covered by a layer of ash and pumice that was thicker than twice an average human height. The nearby coastline also changed dramatically. In today's world, the after effects of volcanic eruptions are often more dangerous than the eruption themselves. Thanks to advances in technology, we can now predict volcanic eruptions more accurately and use safety measures like evacuations and flight cancellations. But there's still a lot of risk that changes in weather patterns and drought all over the world, especially in areas like India, East Asia, and East Africa that are affected by monsoons. Volcano eruptions can also have effects you wouldn't probably expect, like the evolution of dinosaurs. These guys were once the size of cats, waiting for their time to shine. It came around 230 million years ago. This time is known as the Carnian pluvial episode. Before it, Pangaea was a dry and arid supercontinent. But then, there were 4 major volcanic events that pumped huge amounts of carbon dioxide into the atmosphere. Global temperatures and humidity spiked because of it. These massive eruptions most likely happened because of the Wrangellia Large Igneous Province eruption in what is now British Columbia and Alaska. This prolonged volcanic activity created the right conditions for dinosaurs to blossom and diversify, and also for the rise of other groups, like modern conifers, ferns, crocodiles, turtles, insects, and early mammals. With higher temperatures and more rainfall, terrestrial plants have evolved, and humidity-loving ones have become dominant. Without those changes in the world, we could have a completely different natural history. There's some solid proof that volcanic activity has really changed the weather patterns back then. Scientists have found layers in the Earth's core that show different types of carbon. It means there were 4 massive releases of carbon dioxide into the atmosphere. The data on mercury and carbon together shows that the spike in mercury levels was thanks to a major volcanic event that affected the global carbon cycle, and not just local eruptions.
So, you might have heard that Yellowstone National Park is sitting on top of a giant supervolcano. That's a reason why the area can boast powerful geysers and hot springs. But it also means that underneath Yellowstone, there is an enormous magma chamber. In 2015, researchers from the University of Utah found out that this chamber was much bigger than everyone had previously thought. They even found one more reservoir with magma under the top one. Apparently, the more spacious the chambers are, the more magma they contain. Together, the two reservoirs store a glob of magma that could easily fill the Grand Canyon not once, but 11 times. But you know the most worrying thing about the magma chambers? They tend to push against the ground above them. As a result, the land in Yellowstone rises about 1 to 2 inches a year. On top of that, Yellowstone has the status of an active volcano, and its volcanic explosivity index, yes, there is one, is 8 out of 8. Such a high number means that if this volcano erupted, it would be an apocalyptic event. To put it into perspective, the eruption of Pinatubo in the Philippines in 1991, which is considered the most powerful in living memory, was given a mere 6 on the volcanic explosivity index. Ha, loser. Now, let's figure out if there's anything to worry about. In March 2023, the University of Utah seismograph stations recorded 354 earthquakes in the entire region of Yellowstone National Park. Sounds like a lot. But keep in mind that the most impressive event of the month was a mini earthquake of magnitude 3.7. It was part of a swarm of 106 earthquakes that began on March 29th and continued until the end of the month. Yep, earthquakes apparently also come in swarms, so be aware. Experts say that Yellowstone's seismic activity is, well, kind of more active than usual, but it's really nothing serious. A geophysicist working at Yellowstone Volcano Observatory called Michael Pollan claims that the volcano won't erupt anytime soon. For this to happen, there must be enough magma ready to erupt beneath the surface. Whew. There should also be enough pressure to cause this magma to rise. But neither of these conditions exist today. According to the expert, Yellowstone is stable now. At the same time, Pollan and his team are keeping track of all kinds of underground activity, looking for warning signs of possible eruptions. Some of them can be the frequency of earthquakes and ground deformation. Thousands of mini earthquakes, coupled with extreme changes in the surface of the ground in that area, can be alarming. The team also monitors the temperature of the park's thermal features. That's another noteworthy sign of a potential disaster: park-wide changes in geyser activity, as well as gas and thermal emissions. So, despite the media claims that Yellowstone is due to erupt soon because the last eruption happened 70,000 years ago, that's not how volcanoes work. Experts say that it's one of the most popular misconceptions about volcanoes. They don't follow timelines. If a supereruption did happen, though, the most worrying thing for us would not be the lava flows, and not an earthquake that would most likely accompany the natural disaster. No, the worst consequence of such a supereruption would be ash and ashfall. Let's have a look at what it was like when the Yellowstone volcano erupted many years ago. There have been at least 3 supereruptions in the history of the volcano. The most powerful of them was 2,500 times more devastating than the terrifying eruption of Mount St. Helens in Washington state in 1980. As for the most recent supereruption, it was dubbed the Lava Creek eruption. It formed the Yellowstone caldera after spewing out an insane amount of dust, volcanic ash, and rock into the air. Recently, scientists have also learned about 2 other previously unknown supereruptions that happened around 9 and 8.7 million years ago. The younger of the 2 is now considered to be the largest recorded event of the whole Snake River Yellowstone volcanic province. Anyway, let's have a look at what was going on all those millions of years ago. Because I wasn't around then, so we're all assuming this stuff based on evidence. The first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, the heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust and leaving behind huge chambers. They were filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding since more and more magma arrived with time. The land over the volcanic system was rising upward almost unnoticeably. A year before the supereruption, Yellowstone gave a warning, a burp maybe. But that long ago, there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression releases gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging in that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up. This created a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle of soda after you've shaken it. Something like that was happening near the volcano. Think Mentos and Diet Coke. The pressure was released through the fractures when gases were bursting out from under the surface. So right before the disaster, the ground around the Yellowstone volcano lifted. Geothermal pools and geysers heated up to boiling temperatures and got more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe. But the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash hurled up into the air. Within several minutes, a pyroclastic flow rushed across the area at a hurricane-force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot expanding gases. It looked like an extremely hot toxic snow avalanche. With a temperature of about 1300 degrees, it was burning everything in its path. The volcano kept pumping ash for days on end. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds of being inhaled. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a thick layer of ash covered huge territories. After the ash got into the stratosphere, the temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sunblocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing supereruption, was colossal. That's how researchers described it in their recent studies. It affected a huge territory. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. Now, if such an eruption were to happen these days, it would cover Colorado, Utah, and Wyoming with almost 3 feet of toxic volcanic ash. Many regions would be plunged into darkness. Even the coast, where most Americans live, would experience problems with the spread of the ash cloud. It would destroy crops and contaminate pastures, ruin power lines and electrical transformers. Well, so I'm sure you'll agree with me, it's a good thing that such a disaster isn't expected to occur anytime soon. Hey, we got enough other stuff on our plate.
For 70,000 years, Taftton volcano successfully convinced everyone it was extinct. But new satellite images show that its summit is rising, like something inside is stretching it, rolling it over, and cracking its neck after the world's longest nap. Scientists aren't too happy about it, so let's see if you have a reason to be worried too. Volcanoes can wake up when earthquakes shake them awake or storms mess with underground water. But scientists checked. There weren't any big earthquakes or heavy rains in southeastern Iran, where it sits. So it must be gas or magma pressure that's moving Taftton. It's like a sealed soda can heating up from the inside. Before you even hear a hiss, the pressure is building silently, waiting for a weakness. That's why Taftton's movement is such a big red flag. Pressure changes mean new internal activity. Plus, the source of pressure below its surface is at just around 1,600 to 2,070 feet deep. And that's not a lot for a volcano. When the source of pressure sits that close to daylight, it can set off small explosions from steam or gas, even if no lava ever touches the surface. This type of explosion, called phreatic, happens when water underground gets so hot so fast that it blows up like a giant pressure cooker. In Hollywood movies, volcanic eruptions always look like rivers of lava chasing people down the street. But steam-driven explosions are different, sneaky, and unpredictable. One minute everything looks calm, and the next minute rocks and superheated steam blast into the air like Earth sneezed with the power of a jet engine. For Taftton, this is exactly the scenario scientists are afraid of. You don't need flowing lava to cause destruction. A steam-driven explosion can launch boulders the size of cars and shoot ash clouds thousands of feet up. Even if you don't live anywhere near Iran, Taftton isn't just a local issue. Volcanoes breathe out gases that travel with the wind, and Taftton produces sulfur-heavy emissions when it's active. Sulfur dioxide doesn't just smell bad, but messes with air quality, irritates lungs, and reacts in the atmosphere to form particles that can dim sunlight and cool temperatures. That means neighboring countries might feel the effects even if they never see the volcano. And if a phreatic explosion blasts ash high enough, it could drift into international flight paths like volcanic confetti nobody asked for. Even smaller eruptions can have ripple effects. Remember that time a volcano in Iceland with a name I won't ever pronounce correctly blew up in 2010? It disrupted all the air travel across the Atlantic, and in our case, a modest ash plume drifting into major air corridors could ground flights across the Middle East, South Asia, and beyond. You know, gas emissions don't respect borders. They drift, mix, and settle wherever the wind decides to drop them. Alright, all this sounds pretty creepy, but with all the modern sensors, scientists should find out about an eruption in advance, right? Not really. As Taftton sits in a really remote region, setting up monitoring stations there is tricky, expensive, and frankly, was never a priority because everyone assumed the volcano was done for. So right now, satellites, not ground instruments, are doing most of the work. Satellites see the big picture, but instruments on the mountain add detail. And that's why it was so important for Taftton to be reclassified from extinct to dormant. Because dormant volcanoes need eyes on them 24/7. When a volcano is labeled extinct, countries don't invest in evacuation plans, hazard maps, or monitoring equipment. Changing Taftton's status forced everyone, from local officials to global scientists, to admit it can cause trouble. And that means preparing for ashfall, gas emissions, sudden eruptions, and the long-term questions. Questions like, what if this awakening isn't temporary? What if this is the beginning of a whole new activity cycle? Long-term, Taftton might settle down again, or it might be entering a period of renewed activity. Volcanoes don't run on human timelines. A short-term phase for a volcano could be days or years, and the uplifting summit might mean there's deeper magma movement, not just a surface burp. It has gone up by about 3.5 inches over 10 months between July 2023 and May 2024, and a mountain rising is like Earth inhaling. And if Earth inhales too deeply, it eventually exhales. And in volcanic terms, that exhale is nothing good. Right now, Taftton is breathing in, and nobody knows when it plans to breathe out. This already sounds like too much drama, but there's more where it came from. Some of the biggest, angriest supervolcanoes on Earth are starting to wake up. When one of these monsters erupts, the whole planet feels it, even people living thousands of miles away. Scientists worry because a super eruption could move faster than our ability to prepare food, evacuate cities, or deal with the chaos afterward. That's what makes supervolcanoes so scary. Not just the explosion, but how little time we might have to react. If you live near Naples, you already know at least one supervolcano and how it acts. Streets crack, steam leaks from the earth, the harbor fills with sediment, and swarms of small earthquakes rattle windows like underground thunder. All of that comes from Campi Flegrei, a massive supervolcano caldera that last erupted in 1538. For years, scientists read these signals as classic warnings of magma rising. But two recent studies, one in 2023 and another in 2025, completely changed how we understand what's really going on. And surprisingly, they brought a bit of hope with the danger. In 2023, studies zoomed in on carbon dioxide, a gas volcanoes pump out when magma starts acting up. At Campi Flegrei, CO2 levels jumped after 2005 to about 4,000 to 5,000 tons a day, which sounds like magma rising fast. But when scientists checked other gases like nitrogen and helium, the chemistry didn't fit that idea at all. It turned out that the extra CO2 came not from rising magma, but from super hot fluids underground, cooking the surrounding rocks and releasing gas on their own. In the 2025 study, lab experiments showed that the shaking comes mainly from a sealed underground water and steam reservoir. When that natural lid traps pressure, it eventually cracks and releases steam and sets off sudden quakes that people feel at the surface. That idea also explains something that always confused scientists. The earthquakes usually start close to the surface and then move deeper, which is the opposite of what rising magma would do. After the strongest shaking, the ground often sinks a little, like a balloon slowly deflating after you let some air out. None of this means Campi Flegrei is suddenly safe though. Magma still sits deep underground and steam-driven explosions can still blast out rocks, ash, and scorching gas without any lava warning you first. What's really changed is how scientists think about the danger. Just watching and waiting isn't enough anymore. If humanity only had 12 months of warning before a supervolcano eruption, we'd struggle badly. Stockpiling food, relocating people, keeping supply chains alive. It would all feel almost impossible. But don't freak out yet, because supervolcano eruptions are extremely rare. The last one happened about 26,500 years ago in New Zealand. On average, scientists think a super eruption happens roughly once every 100,000 years, but Earth doesn't follow neat schedules like a calendar. Sometimes these eruptions cluster closer together, and then the planet stays quiet for a long time. Two massive super eruptions shook the planet within the last 100,000 years. About 74,000 years ago, Indonesia's Toba volcano blew up with such force that it blasted ash across Asia, lowered the temperatures around the world, and may have pushed early humans to the brink of extinction. Then, around 26,500 years ago, New Zealand's Taupo volcano unleashed an eruption, covering huge areas in ash and reshaping the landscape we see today. There's always a chance another super eruption could arrive earlier than we expect. That uncertainty is what keeps scientists awake at night.